Alright, so in this video we're covering the section of the book 10.4 about counting techniques. And ultimately what our learning target is going to be about is combinations and permutations and being able to count the number of possibilities in a real world context, eventually using some formulas that we're going to provide you about these two different types of problems, combination problems and permutation problems. So first, let's just talk about a simple counting problem. So this is not an example of a permutation or combination, but this is a more simple example of a tree diagram and how we can do actually, we can count the number of possibilities without actually having to go through the work of making a tree diagram. So suppose you take your little brother out to a fast food restaurant for dinner. Kids meal allows him to choose between 4 burgers, 3 drinks, and 2 desserts. How many meal possibilities are there? So what I'd like you to add to your notes, so either on a separate sheet of paper, I think that would be what I would prefer, or if you feel like you can fit, we're going to have this definition plus 2 more extra definitions than from what's on your note sheet. So I would say grab another sheet of paper, but we're going to talk about the counting principle. So the counting principle says that if there are A ways to make a choice, and for each of those A ways, there are B ways to make the second choice, and then for each of those there are C ways to make a third choice, and so on. You can use the product A times B times C, etc., to find the number of possible outcomes. So for this one, there are 4 burgers, 3 drinks, and 2 desserts. There are 4 strands for the burgers, and after you choose one, then there are 3 different possibilities for each of those, which is why we do 4 times 3. That tells us that after we've chosen a burger and a drink, there are 12 total different possibilities. Then we multiply that by 2 because every single burger and drink combo has 2. All 12 of those has 2 possible desserts. We multiply all those together to tell us that there are 24 meal possibilities. This is the counting principle. And this works every time without actually having to go through the extra work of making a tree diagram. Okay, so for example, when we talk about like a license plate, let's say we're only talking about license plates with 6 digits space in between, and let's just say that the first 3 are letters, so there's 26 choices for that. 26 choices for this one and 26 choices for this spot, because remember in a situation like this, we're actually repeating letters, okay? So we could have A. So we don't want the numbers to get smaller in this example. We don't want to multiply by 25 for the second one, like we did in this one, 4 times 3 times 2, because there are 25 options. There are 26 options for that next one. So you have to think about that when you're as you're going through. And then maybe these are numbers, so there's 0 through 9, that's 10 numbers for each one. So you'd multiply all of those together to find out the total number of different license plates that you could get. Okay. All right, so here's what I was talking about. I want to have the definition for permutation, which is in your notes, but then we need to add 2 more. And we do need you to leave room. Like I need there to be space between here and here, because we're going to add to the definition for permutation and combination in class. I'm going to actually give you a formula for each one. So right now we're just going to talk about how to distinguish between a permutation and a combination. Okay, so a permutation is an arrangement of choices when order matters. So like the license plate, that would be an arrangement where order matters. It's not the same to have a license plate that says ABC 1, 2, 3. That's not the same license plate as CBA 3, 2, 1. Okay? The order that we put those letters and numbers in really matters. So that would be a permutation. Okay? An arrangement that's called a combination is one where the order does not matter. So for example, if I'm choosing a committee and maybe I have 20 people to choose from and I'm going to choose 3 of them. And there's no particular, it doesn't really matter. It's the same to me if I choose Billy, Gabe, and Austin. that's the same committee as if I chose them in a different order, maybe then Austin, then Billy, then Gabe, okay? So the order doesn't matter in that sort of situation. Okay. And then a factorial. This is going to be important that we know what this means. I know we talked about this in class a little bit. This is going to be a part of what we need to do for the formula for permutation or combination. So a factorial is for only any integer n that's greater than 1. Okay, so it doesn't work for anything bigger than that or anything smaller than 1. N factorial is written n with an exclamation point, and that is the product of all the consecutive integers from n decreasing to 1. So for example, 5 factorial is from 5 to 1, it's the product, so I'm going to multiply every single consecutive integer, so every number in a row decreasing down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, and that works for any number greater than 1. We can do a factorial for those. All right, so going on to example B, we're actually not going to answer any of these questions here. Okay, so we're gonna skip over these for now. Don't actually cross them out on your notes, but I'm just going to talk about if this is a permutation or combination, and then in class we'll talk a little bit more about how to actually answer these questions. So you're redecorating your room. You have 5 pictures to arrange in a row along one wall. The pictures are labeled A, B, C, D, and E. How many different ways can you arrange the 5 pictures? That's the question, okay? So in this one we're actually talking about arranging them in a row, and it probably, maybe to some people it doesn't matter, but we're just saying that in general it is different the order that you hang up your pictures, okay? A, B, C, D, E is different. It's a different order. We're going to count it as a different possibility of the way that you can hang your pictures than putting them maybe in a random different order, okay? These are totally different, okay? And all of them we're choosing all 5 pictures, but we are going to count all of the different orders that you could put them in. And for example, also another question that we're going to talk about is what if you're only choosing 3 pictures? So you could choose A, B, C, or you could choose 3 totally different ones, D, E, and B. Or A, B, C is not the same thing as B, A, C. Even though those are the same pictures, they're hung up in a different order. So also, how can we calculate all of the different ways to arrange them if we're only going to hang up 3 of our pictures? So all of these situations are called a permutation, okay? Permutation, as we wrote down in our definition, is when order matters. And I remember this by the word placement, because permutation goes with anything where we're thinking about where we're going to place things, okay? And then I'm going to add one more example in there. Don't worry about writing all this down, but maybe just write this first sentence. A piggy bank contains 6 coins, dollar, half dollar, quarter, dime, nickel, and penny, and you can abbreviate those. Okay, and then we're talking about shaking the bank until 3 coins fall out. So maybe write that down too. If you shake the bank until 3 coins fall out. And we're just thinking about how many different sets of coins you can get. So this is kind of like that same problem where we picked marbles out of a jar, and we didn't care what order we picked them out in. We just wanted to know how many different color combinations we could get. So this is what a combination is talking about, where the order doesn't matter. We don't care if the penny falls out and then the nickel and then the dime, or if maybe it's the dime first, then the nickel, then the penny, or penny first and then dime and then nickel. These are all the same thing to me. We're going to count those as the same possibility, because really, if you think about it, if you're shaking money out of a piggy bank, you just want to know how much money you're going to get, right? So we just want to think about the ways, the different combinations, meaning I don't care about the order. These and all of the other ways that you could arrange those three different coins, those all count as one combination when you're counting, okay? before class, how many student identification numbers can be assigned if an ID number consists of any 2 letters from the alphabet followed by 3 digits? So we're doing a 5-digit ID number. This one, the first 2 is a letter, and the last 3 is any digit, so 0 through 9. Okay, so I want you to come to class with how many different numbers can be assigned for a student identification number.